Hello everyone, welcome back to Brain Power Classes. Today we are going to start with class 11th Earth Moments part 2. In part 1 we already discussed about faults, folds, earth moments, in that slow moments, evidence of earth moments. We discussed these four peaks and the we done with the geographical explanation. Today we are going to start with the Rift Valley. So what is Rift Valley? When the land between two parallel faults sinks, it forms a rift valley, which is also called as Garben. So, what are the characteristics of rift valley? It is deep valley. You can say in this pic, it is deep. It is deep and steep. Both walls are steep, and it is deep. It has deep undergone. So it is formed due to tensional forces. Like we can have examples are African Rift Valley, Narmada Valley, and Tapi Valley. So this was all about the Rift Valley. Now we are going to move with the sudden moments. So what are the sudden moments? Till now we studied slow moments. Now let's understand sudden moments. These occur within a few seconds or minutes due to the sudden release of energy inside the earth. The two major sudden moments are earthquake and second one is volcanic eruptions. Earthquake, you can see the picture here. So what is earthquake? So an earthquake is the sudden shaking of the earth's surface. It is the sudden shaking of the earth's surface known as earthquake. So inside the earth's crust, stress keeps building because of the tectonic forces. You can see here, here is the earth's surface, epicenter, focus, all you can see here, secondary waves, primary waves. It is all there, we have to label that. So when this stress exceeds the strength of rocks, it is released suddenly as energy, and this energy travels in the form of seismic waves, causing the ground to shake. So this is earthquake. Now in this, what is focus, what is epicenter? So the point inside the earth, you can see here, point inside the earth where the earthquake begins is called the seismic focus, the black dot. The point directly above it on earth surface is called the epicenter, which is here. So the strongest shaking is felt at the epicenter, and the intensity decreases as we move further away from the epicenter, from the focus. Now, how earthquake is measured? So it is measured by seismograph. The instrument used to record earthquakes waves is called seismograph. It helps scientists to measure the strength and the timings of earthquake. What are the seismic waves? Earthquake energy travels through the earth as seismic waves. The you can see in the text in this here 1.10 shadow zone of an earthquake. In this you can see also in this paragraph you can see that P waves can travel through solids and liquids, but S waves, secondary waves, can travel only through solids, not in liquids. So because of Earth's outer core is liquid, S waves cannot pass through it, creating an S waves shadow zone. This S wave shadow zone. So similarly, due to the bending, which is called refraction of P waves at the core, there is also a P wave shadow zone where direct P waves are not detected. You can see here solid inner core, liquid outer core, P waves, S waves, epicenter, all it is mentioned in this shadow zone of an earthquake diagram. So this information helps scientists understand that the earth's outer core is in liquid state. Now what is shadow zone? So whenever an earthquake occurs, energy is released in the form of seismic waves. There are mainly three types of seismic waves: primary waves, that is P waves; S waves, that is secondary waves; surface or longitudinal waves. So among these, P waves travel through solids, as we discussed now, solids, liquids and gases, whereas S waves travel only through solid materials. They cannot pass through liquids. Although P waves can pass through every medium, their direction changes when they move from one medium to another. This bending of waves is called refraction. Now, an interesting question arises is कि if an earthquake occurs, do all places on Earth receives its seismic waves? So, what do you think? The answer is no. There are certain areas on the Earth where the seismic waves of a particular earthquake are not recorded by seismographs. Such areas are called shadow zones. So remember that shadow zone is different for every earthquake because the location of the epicenter changes. Let's understand by the figure. You can see here the figure 1.10 shadow zone. It is clearly mentioned here: solid waves, liquid waves, P waves, shadow zone, S waves, and crust, no direct waves. It is clearly mentioned here. So between 105 degree and 140 degree, neither direct P waves nor S waves are recorded. Therefore, this region is called the shadow zone of both waves. Beyond 140 degree, P waves are again recorded because they are refracted inside the earth. However, S waves are still not recorded because they cannot pass through the liquid core. Therefore, the S wave shadow zone is much larger than the P wave shadow zone. This concept also helps scientists conclude that the outer core of the earth is in liquid state. Now, just one thing remember: 0 degree to 105 degree, both primary and secondary waves are recorded. 105 degree to 140 degree, shadow zone for direct P, that is primary waves, and S, secondary waves. Beyond 140 degree, only primary waves are recorded. Now, what are the causes of earthquake? So first is volcanic activity. Sometimes earthquakes are caused by volcanic eruptions. So when magma moves upward inside the earth, it creates pressure. This pressure produces vibrations causing earthquakes. These earthquakes are usually shallow and affect only the nearby region. You can see, for example, the earthquakes near Mount St. Helens in 1981. It is mentioned as an example. Second is tectonic movements. This is the most common cause of earthquakes. The Earth's crust is divided into many tectonic plates. These plates are continuously moving over the mantle. So, when two plates collide, separate, or slide past each other, stress builds up, and when this stress is suddenly released, an earthquake occurs. Like examples we can see is Indonesia, California, Chile, Uttarkashi, and Assam. So most earthquake occurs along plate boundaries. Next is anthropogenic causes. So these are human activities. Sometimes earthquakes are caused by human activities. Examples like atomic explosion, large dams, mining, blasting, deep drilling. These earthquakes are generally small and affect only a local area. Now, earthquake zones in India. It is like on the basis of intensity of damage risk. India is classified into 5 risk zones. By using this link, we have to complete that. So, zone 1 carries low risk. Sorry, zone 2 carries low risk. Zone 3 carries moderate risk. Zone 4 carries high risk. And zone 5 carries very high risk. So areas like Northeast India, Jammu and Kashmir, parts of Himachal Pradesh, Uttarakhand, Gujarat, and the Andaman Nicobar Islands fall in the highest risk zones. Now, what are volcanoes? So now let's move to another sudden moment, that is volcanoes. So a volcano is an opening in the Earth's crust through which magma, gases, and solid materials come out onto the Earth's surface. Now, when magma reaches the surface, it is called lava. So this was all about what is volcano. What is volcano? Now, in next video, we will see volcanic materials, geographical explanations, and the types of the volcanic landforms. So till then, thank you everyone. Keep learning and keep growing with brain power classes. See you in next video.